Lieutenant Commander Dr. Buxton, Royal Canadian Navy retired, and his lovely wife Sue in support, as always. Sue, nice to see you. So, a little bit of history about Roger, and I didn't know all of this, so forgive me, you may have known, but I didn't. Roger joined the Royal Military College of Canada in 1957 and graduated 4 years later with a diploma in chemical engineering and a Bachelor of Science degree. He later completed a Bachelor of Arts in History and International Relations. You think with all that science degree background, he'd opt for life other than a seaman officer. He could perhaps be an engineer, but he didn't. He opted as a seaman. And his initial sea training included 3 months in HMS Oryx, which was an A-class submarine in the Royal Navy's 6th Submarine Division based in Halifax on the East Coast. While he was recommended for service in submarines, he declined the offer to train and serve in the Royal Canadian Navy's new Oberon-class submarines, which was about to be introduced. Instead, he completed the Long Weapons course, a combination of gunnery, ASW and weapons electrical, and then served as weapons officer of HMS Saskatchewan, I can say that too, on the West Coast. During this posting, he made the best decision of his life by marrying Sue, who was a teacher from Box Hill, who was enjoying teaching in Canada. After attending the Canadian Services College on Vancouver Island, he served in HMS Restigouche on the East Coast as weapons officer until the ship paid off into half-life conversion, before he completed the Canadian Navy's Principal Warfare Officer's PWO course. Then, with just 4 days' notice, he joined the Majesty's Canadian ship Navigable, sailing for the Caribbean on the 2nd of January, the middle of winter in the North Hemisphere, and leaving Sue to shovel snow in Halifax winter for 2 months. Next, he served on exchange with the Royal Navy at HMS Excellent in Portsmouth, where he did the Royal Navy Tactical Course and taught tactics for 1.5 years, and then returned to Canada. He spent 2 years teaching tactics at Fleet School Halifax and as a sea rider with the Canadian Officers BWO course, either in local areas or, as he said, preferably off Bermuda. In 1976, he was posted to HMS CS Marguerite, which was a just helicopter-capable destroyer, as the executive officer. In 1978, Roger spent a year in Ottawa on the program management staff of the Halifax-class frigate, and then a year in Toronto as staff at Staff College. He returned to Halifax. He spent 3 years as officers training coordinator at Fleet School Halifax, where he also went to sea again with the PWO courses. And that ended his sea time, as he spent his last year in personnel at Fleet Headquarters in Halifax. It's a long time on the East Coast. And in 1987, faced with a posting back to Ottawa, which he described as having a winter climate colder than Moscow and a summer climate like Singapore, he resigned from the Navy and then moved to Melbourne. Probably the second smartest decision he made. Here he first worked for the Victorian Employers Chamber of Commerce and Industry, and later as Secretary of the Sports Contractors Association. Sue worked for Swinburne, and after a couple of iterations finally retired in 2018. And both of them enjoyed messing about in boats, in their 30-foot sloop on Port Phillip, then Western Port, and their 26-foot motor cruiser on the Gippsland Lakes, and later also on Western Port. And they finally swallowed the anchor 3 years later. They have 2 sons and a daughter who presently live away from Melbourne. So, Roger, I am really glad that you volunteered. Always better than a press man, but genuinely keen to hear, and I'm sure all of us are, what you have to say about exploring and charting the Western Arctic. Thanks, Roger.
Thank you, Andrew. Exploring and charting the Western Arctic seems like a rather strange subject for a talk to this group, but I think it is a very appropriate topic. And I first need to explain what I mean by the Western Arctic as opposed to the whole Arctic. This line around here at 66.5 degrees north is the Arctic Circle. And the Arctic Circle is defined as the point, it's the northernmost point at which the noon sun is visible on the horizon on the 21st of December, which is the northern winter solstice. And also it's the southernmost point at which the midnight sun is visible on the summer solstice in the northern hemisphere. In other words, the 21st of June. So on the 21st of June, everything is light north of the Arctic Circle. On the 21st of December, everything is dark north of the Arctic Circle. And you see that the Arctic actually extends a little bit beyond the Arctic Circle. It includes northern Russia, southern tip of Greenland, northern Canada, and Alaska. Now, I said it might seem like an unlikely topic, but with global warming, the Arctic has warmed faster than anywhere else on the planet. This has major implications both for the environment and for politics and strategy. I will talk about these things at the end of my presentation. Another important thing to remember is that both Canada, Greenland, and Alaska look out across the Arctic Ocean at Russia. Now, I need to confess that my Arctic experience is limited to operating in the Norwegian Sea up here. So the talk is basically based on extensive reading. And I want to acknowledge Ron McNabb, who was a former naval contemporary of mine, who spent many years working with the Bedford Institute of Oceanography. And he's also the retired chairman of the editorial board for the bathymetric chart of the Arctic Ocean. And he provided me with a lot of useful information. So we've seen that already. This is a photograph taken off North Cape, Norway on the 7th of June. And you can see here that the sun is just below the horizon. 2 weeks after this, the sun would have been right here on the horizon. So that's very annoying, that thing. The first European people to explore the Arctic were the Norse, who came from Norway, and they went by the Shetlands, the Orkneys, and in the late 800s they reached Iceland, and then inevitably they reached Greenland from there. In the year 985, Erik Thorvaldsen, otherwise known as Erik the Red, led a fleet from Iceland to the west coast of Greenland. We believe he went across here, down the coast, and there were settlements at this point here, and just up the coast here. And his son, Leif Erikson, was believed to be the first European to set foot on the North American continent. That's well before Christopher Columbus. Now, climate change was very important at this time, and the period between 1400 and 1850 was the Little Ice Age, when global temperatures dropped and agriculture became unviable in southern Greenland, and in about the year 1500 the Norse left. That's an artist's impression of the kind of ships the Norse sailed in. Now, as we all know, in 1492, Columbus sailed across the Atlantic. He landed in the Caribbean. He was hoping to land in China. And 5 years later, there was another exploration trip to Newfoundland. But the only trip to the Arctic at this time was won by a Portuguese called Gaspar Corte Real, who sailed across the Atlantic to the coast of Labrador, up and into Hudson Strait. After this, there were no Arctic voyages for about 75 years. So what sort of charts did they leave? Well, not very much. This is one from 1590, clearly based on the Norse voyages. You see Britain and Ireland, Shetland, Faroes, Iceland, and Greenland. And then moving over here, if you can accept that Helluland is Baffin Island, Macland is Labrador, and this Finlandia is the northern peninsula of Newfoundland. It basically proves that Leif Erikson did actually reach North America. So navigation before 1500. Get rid of that thing, sorry. The magnetic compass was discovered about the year 1000 and it's continuously improved. We believe that the very earliest people sailing across the Atlantic judged where east and west were by the rising and setting of the sun, and they estimated their latitude by the constellation Ursa Major and the pole star at night. This is a picture of the northern hemisphere night sky. This constellation here is Ursa Major. This one is Ursa Minor. And if you go back to Ursa Major, these two stars here are called pointer. And if you run up and go slightly to the right, you reach Polaris, North Star. And so why is Polaris important? Well, it's important because it's basically directly over the North Pole. Now, the Earth rotates on its axis in an eastward direction, so if you're looking upwards at the night sky, the heavens rotate slowly to the west, like this. Okay, this is how it rotates. So over here on the left you can see Ursa Major. I'll watch it again. Okay, here we go, up the pointer. And you find here that all the stars are rotating except Polaris. Actually, it's rotating in a small circle of about 2 degrees, but basically it's stationary. And because it's over the North Pole, the elevation above the horizon of Polaris is very close to your latitude. So this is the way they judged latitude. And also by looking at the position of Polaris night after night, if it starts to drift further up, it means you're going north. If it sort of drifts down, it means you're getting further south. Now, navigation had improved by the late 1500s. This is a description of navigation by latitude and dead reckoning. As you see here, as longitude, in other words, how far east or west you were, could not be determined at sea until the 1700s. Navigation depended on the 3 L's, log, lead, and latitude. And I'll talk about that in a moment. And determining latitude required knowledge of the sun's declination. In other words, how far the sun is above the celestial equator. So, it goes 23.5 degrees north to 23.5 degrees south twice a year. And the astronomers had been calculating and tabulating this information for hundreds of years. It wasn't terribly accurate, but it was something. From the tables they had. And by measuring the altitude of the sun at noon, they got a pretty good estimate of what their latitude was. But they couldn't tell exactly where they were. However, I need to mention that occasionally, surprisingly, if they reached North America and they went ashore somewhere, and if they had a good telescope, which they could not use at sea because in the seaway it's impossible to look at the planets or the stars with a telescope, if some phenomenon, let's say a lunar eclipse took place, using the telescope they could see the eclipse and they could determine the exact time when it took place. When they got back home, they could ask what time did this occur, and the difference in time is the equivalent to the latitude, because the Earth rotates on its axis once a day. In other words, 360 degrees a day, so it's 15 degrees in an hour, 1 degree in 4 minutes. So you could in fact work out where they had been when they got back home. But if you want to know how they do the time without clocks, you can ask me afterwards. I haven't got time to do it. This is a simple sea astrolabe. You sighted along here. You suspended it by this ring, and you read the altitude of the sun or the star along the scale here. It's very heavy, not very good. This is a cross staff, probably somewhat better. This piece is moved backwards and forwards, and the angle is measured along here. And it was considered much easier to use than the astrolabe and the seaway. And there obviously is a modern sextant, an instrument for measuring angles, horizontal or vertical, with extreme accuracy. This is a much later picture of measuring the depth by swinging the lead. The thing is spun around, cast forward, the line falls into the sea. When the weight hits the bottom, the marks on the line determine how deep it is. This only works to about 20 fathoms. There was a system with a deep sea lead, which would record depths to about 100 feet. The procedure for using that was a little bit different. Now, after the Norse and the one trip in 1504 by the Portuguese explorer Gaspar Corte Real, the next voyage was by Martin Frobisher. He made 3 voyages in 1576 to 78 in here, into Frobisher Bay. Not unsurprisingly, he was looking for a way to China and searching for gold. And he thought that the strait here might possibly be the way to China. And as you see here, this map and chart is attributed to the principal surveyor on his last voyage. This is Frobisher Straits. It's now known as Frobisher Bay after him. And this is Hudson Strait, which he calls the Mistaken Straits. But interestingly, if you can read upside down, it says the way trending to Gathia, in other words, the way to China. So he was hoping this was the Northwest Passage. And no doubt in the middle of the Atlantic, there's a mythical island called West England. Spread back chart, not accurate, no soundings. Immediately after Frobisher's voyage, there were several others by people who were very famous in Arctic exploration. Davis explored in the Davis Strait, and Bylot and Baffin explored in Baffin Bay, and they decided that there was no way to the Pacific from Baffin Bay. And in the early 1600s, there were numerous voyages into Hudson Bay. But the area that particularly interested them was up here, because they were looking again for a Northwest Passage. So they were looking at Chesterfield Inlet, Wager Bay, and Rose Welcome. And they were quite hopeful at one time because there was a very strong tidal stream coming out of here, which they thought must mean that the Pacific was not far away. Unfortunately, it was the flood tide coming in here and coming out there. A couple of the explorers are worthy of mention. The first one would be Henry Hudson. He wintered in the southern part of the bay in 1610. In the spring, he wanted to start exploring again, but his crew had a different idea. That they put him and 6 people into an open boat and cast them adrift. And the first mate, Bylot, took the ship back to Britain, and surprisingly, he was pardoned for bringing the ship home. Another interesting voyage was by the Dane James Monk, 1920. He managed to get his ship home with only 2 survivors from his crew of 63. How he did it? He did. An artist's impression of Henry Hudson and his son. This is a chart by Henry Hudson, which made it back, although he did not. Not really very much use. Hudson Strait, Hudson Bay, very inaccurate. And note this mythical island is still here in the middle of the Atlantic. This was won by James Monk. He was the one who took the ship home with only a crew of two. Cap Fargo, southern tip of Greenland, and I find this very hard to interpret exactly what all these passages are. This is one of the better ones by Luke Fox in 1635. And the last one of Hudson Bay was by Captain Middleton. And there are a lot of bearings and some soundings in here, but still not very good. And up to this point, there was no Arctic exploration for about 200 years. Now, I mentioned that they could determine their latitude fairly accurately, but they could not determine their longitude, so they really didn't know where they were. This was such an important fact that in 1714, the British government established a board of longitude, which offered the price of £20,000, which is the equivalent of £30 million today, for anyone who could determine longitude with an accuracy of 30 miles. First people who succeeded and received some of this money were Professor Meyer from the University of Göttingen and Professor Euler from the University of Berlin. And they set up tables for working out longitude by lunas. Lunar was a very difficult method. It required simultaneously measuring the elevation of the moon, the elevation of the star, and the distance, the angular distance between the two of them. It was hard to work out, but it could in fact give longitude. Apparently this was the standard method by the year 1810, and Cook used this method on his voyages. The next method of determining longitude was by the chronometer, an accurate watch or clock. An Englishman called Harrison finally produced a very accurate chronometer. The test was to send it from the UK to Barbados and back by sea. It lost 1 minute 53 seconds over a period of 5 months. And the advantage of determining longitude by the chronometer was that provided you could see one heavenly body which you could identify, and you could see a good horizon to measure the altitude of that heavenly body, you could work out your longitude. Finally, in 1767, the British produced the first nautical almanac, which is a book which contains data on stars and planets, the sun, etc. And even though Britain and France were at war at the time, this was considered such an important advance that copies were given to the French. In 1815, the Napoleonic Wars ended. The Navy was greatly reduced in size, and instead of fighting battles with the French, naval officers now wanted to go out and explore. Exploration was very important. The Navy actually produced a book which I have with me somewhere, probably over there, the Admiralty Manual of Scientific Inquiry. It was published in 1819. This is the Arctic Council. There were two other big groups involved. One was the Royal Geographic Society and the other was the Royal Society. And because of the pressure that they exerted, in 1819 there was a voyage to the Arctic by John Ross and William Parry. They came up here, they went right up to Lancaster Sound, and they very nearly got all the way through. But John Ross, who was in charge, thought he could see mountains ahead. He called them the Croker Mountains. The mountains did not exist. This, in fact, destroyed his career and prevented him from being used in Arctic exploration again. This is Parry, who was with him. He made 3 voyages in Heckler and Fury, and both Ross and Parry carried out exploration and mapping on the ice in winter using theodolites, which I'll talk about a little while later. Now, by this time, it was considered that almost everything was known, and it was time to finally find the Northwest Passage. So, in 1845, Sir John Franklin set off with Erebus and Terror, and as we know, ships were frozen in, everyone died. Now, the Hudson Bay Company operated in the southern Arctic islands and the Barrens in the north of Canada, and they had a Royal Charter which required them to carry out scientific research. They were afraid this charter would be cancelled if they didn't do any, so they had several people who explored, particularly this man here, John Ray. In the mid-1840s, he adopted the Indian and Inuit lifestyle. He was a great explorer. He mapped 1,750 miles of the coast, and he discovered the final link in the Northwest Passage, Bay Strait. Another great explorer was Captain McClintock. He made 3 journeys with extensive sledging trips on the ice, including, as he described it, one brutally demanding trip of 1,400 miles. Now, this is what was known at the time when the Franklin expedition set sail. See, they knew the southern Arctic, they knew a bit of this passage, the rest of it was blank. The northern islands were largely unknown. Between 1848 and 1859, there were more than 40 expeditions looking for signs of abandoned ships. And in that period, this whole area was opened up, and only the farthest north and west islands remained undiscovered. Now, at this point, it's probably useful to talk about sea ice. This is sea ice extent for the present year. This is in March, which is the greatest extent of sea ice. And this is last September, which is the minimum extent of sea ice. We'll go to some interactive. This shows how the ice develops in early March. And I remember years ago leaving St. John's, Newfoundland, right here in March, crossing the Atlantic and having to detour to the south to get round the pack ice. This is in late summer, which is the best time for navigation in the Arctic. And just as a matter of interest, I'll try and show where the Northwest Passage actually is. There's the southern route along here. Go up through here, go through Bellot Strait and out here. And if you can, try and get through the Perth Strait here, straight through. But that's not always possible, even in good years, because this my laser pointed back. Yeah. Because this area here tends to block up with ice very badly. Now, surveying. This is actually part of Cook Island in Whitsundays, but I want you to imagine that it's an island somewhere in the northern Arctic. It's in summer, and you can navigate by sea. Now, when you're navigating by pilotage close to land, the situation is that you know where the land is, and you take bearings or ranges from the land to determine where you are. But if you're exploring and discovering things, the situation is reversed. You hope you know where you are, and you don't know where the land is. And the Admiralty instructions for doing a running survey are to establish your position. Again, establish your position, take a bearing of a prominent point of land, and then you head off on a particular course. And when the bearing is changed considerably, Take another bearing. You now know this distance, you know this angle, you know this angle, so you can solve this triangle and you can locate this position exactly. And you will continue down the coast doing the same thing. This is a picture from the 1950s, I think, of a dog sled. The British didn't use dogs, they preferred to pull the sleds themselves. I don't know why. And the best time to do surveying was in the early autumn or the late spring, when it was still daylight and the ice was strong enough to move on. So it was done by pulling a sled, which had a wheel on it, which rotated and measured the distance. We go back to this mythical island again. Again, you have to establish your position here, and then take on a particular azimuth, you head off for a point of land, measure the distance, and so on, all the way around the coast, establishing these points. The only difficulty with this method, which is a traverse, is that you don't have triangles, so your accuracy is not as good as if you're doing triangulation all the time. They would measure the course they were on by using a surveyor's compass, which has problems in the far north because the North Pole is not the same as the magnetic pole, or by a theodolite. These actually were in use from the mid-1700s. Theodolite can measure the vertical or horizontal angle with extreme accuracy. We come now to the mid-1850s. The emphasis seemed to be on reaching the North Pole. And the route up here, through Smith Sound, became known as the American route. And then in 1875, the British had an Arctic expedition. It was led by Captain Nares, who was the captain of HMS Challenger. And you may remember Challenger made a round-the-world scientific expedition. When he arrived in Hong Kong, he found a telegram there telling him to get back to the UK immediately because he was going to lead this expedition. The expedition consisted of 3 ships. There was Alert, the main one, Discovery as a safety backup ship, and Valorous, a store ship. They got way up here and they wintered at a place called Floberg Beach, just over 82 degrees north. Now remember that the main ship was called, sorry, not there yet. This says Discovery, backup ship, frozen in 1875. This is Canadian Forces Station Alert. It's right at the tip of the landmass. It's the northernmost inhabited place in the world. Looks out across the Arctic Ocean at Russia. Population of about 65. And it's a signals, intercept, and atmospheric research station. And named after HMS Alert. We get to the 1900s, and this is a period of the Scandinavian ascendancy. Northern Skold, who was a Swede, he achieved the Northeast Passage across the top of Russia. And Sverdrup, as captain of the ship Fram, and Manson, they drifted across the polar basin during a period of 3 years, and they would have been taking soundings through the ice all the time as they did that. And Sverdrup and Amundsen explored between 1896 and 1902 in the Arctic archipelago. That's 4 winters on the ice. And Sverdrup playing some of the islands he discovered from Norway, which was a bit embarrassing because Canada also claimed more. This was resolved by negotiation and a payment to Sverdrup. And during this period, there was more discovery and surveying than in the 30 years of the Franklin search. And you may remember that Amundsen was the first person to achieve the Northwest Passage. I'm trying to get back to my notes here, because I can't remember how you pronounce the name of that ship. It's something like Huya, I think. This shows the tracks of Sverdrup's explorations. And this is Roald Amundsen, and on his ship Ua. This is the one that they achieved the Northwest Passage on. That's Amundsen on the left. The next transit of the Northwest Passage was by a Royal Mounted Police schooner, St. Roche. Took 3 years from 1940 to go from the west to the east. And then in 1944, it went back again in 3 months. Now this ship is preserved in Vancouver, and if you're ever there, it's well worth a visit. This is Vilhjalmur Stefansson. He had Icelandic parents, he was born in Canada, went and lived in the United States, and the Canadians decided they needed to have an Arctic expedition, which went from 1913 to 1918. It was supposed to be Canadian, but they couldn't find enough experienced Canadians, so they went out to the Empire. There were Brits, New Zealanders, and Australians involved in it. Stefansson was a great explorer, but he was rash to the point of being foolhardy. And while the ship was frozen into the ice, he went off on a hunting expedition with some people, left the ship. The ship was crushed and sank, and 8 men died trying to reach the shore. And as it notes there, the Australian Hubert Wilkins was one of the lucky ones who reached the shore. That's Carla, trapped in the ice. Those are the voyages of Stefansson. You see, he went right up to the far north, out on the ice. Just a quick look at the way the water moves in the Arctic. See, it rotates in an eastward direction here, and then a transpolar drift comes out here, which explains why it was so difficult to reach the North Pole, because if you're leaving the north of Greenland and trying to reach the pole, every step you go in this direction, the ice is moving you in a different direction. This is a Soviet ice station, which would slowly rotate around the pole. Another way of exploring under the ice. This is HMS Trenchant. I wouldn't have been very happy standing there taking that photograph, actually. If you look in the background, you see this ice here. This is a pressure ridge. The pressure ridge can extend up to 200 feet below the ice. And when USS Nautilus went under the North Pole in 1958, they had to make 2 attempts to get through Bering Strait because there wasn't sufficient clearance under the ice. Soviet Union releases data by nuclear submarines, but not as actual soundings, simply as contours. The Americans released data in 5-year blocks, and my friend John McNabb, who saw all this stuff, said that it was noted that their tracks never went anywhere near the Soviet area. You can believe that or not. Now, by the end of the Second World War, all the northern islands had been discovered, but they weren't exactly sure where they all were and how it all fitted together. So they used Lancasters to do photographic mapping. Between 1947 and 53, they produced some 4 billion negatives. And even when that was done, there was still some doubt about exact locations, so they had to go one step further. And they used a system called SHORAD, Short Range Aid to Navigation, which was used in late World War II for bombing. And they had to set up 2 stations, which would be a couple of 100 miles apart, and the aircraft, which was fitted with a radar, would fly a transit across the line, hopefully at 90 degrees, and measure the echo, which was sent back by a transponder on each of these sites. And by doing that, they were able to determine the distance between the 2 stations. For each line, they made 2 sets of 8 transits, and if the distance was more than 50 feet, they would do the whole thing again. This shows the lines that they used in SHORAD. This was tied into the American grid and to the Greenland grid. But just as an example, what they might have done is set up these 2 stations here, 16 and 27, and they determine that distance, and they put another station up here to determine the distance here, and then they would then determine the distance here, and then knowing the lengths of the 3 sides of that triangle, they knew the exact positions of all those points. Blow that up a little bit. If I can, which I can't, keep it the way it is. That's the International Bathymetric Chart of the Arctic Ocean, version 1. And it shows the deep areas in the dark blue, the light areas in sort of green. The very interesting thing is this Logonosov Ridge, the shallow water that runs across through the pole. And because it's joined to their coastal waters, Russia start claiming that they actually have the North Pole in their economic zone. And Denmark and Greenland and Canada are also suing this one up here. Now, conventional hydrographics today is still going on, using side-scan sonar and LiDAR, which is using laser beams from an aircraft, one of which bounces off the surface, the other one bounces off the bottom, and enables you to determine the depth. I need to point out that according to the latest information, in the Canadian archipelago, 15% of all the waters and 40% of the shipping channels are surveyed to modern or adequate standards. So in other words, you tend to follow the line of soundings. Now, I mentioned earlier on that because of climate change, there is more open water in the summer, and that this has environmental impacts. This is the ship going through Bellot Strait, and you can just imagine the possibilities for accidents here and oil spills. So that's what the environmental impacts are. Now I've got a few slides here which slightly off the subject, but I think they're interesting. This is the first Arctic and offshore patrol ship, Harry the Wolf. It was taken off the southern coast of Devon Island in the high Arctic last year. It looks a very tiny ship. Actually, it's over 6,000 tons, and it was on its transit of the Northwest Passage at the time. Now, because of all the problems in the Arctic, especially with Russia, and also fears that people are going to start creating environmental havoc there, the Canadian government has established a naval facility at Nanisivik in the high Arctic. That's a photograph of a patrol boat taken several years ago at the old jetty. There used to be a mine here, and the mine has been closed for 7 years, so they took that as the starting point. This is now the new jetty, the naval facility, And I understand that this is intended to operate from July to December annually. I think initially it was supposed to be year-round, but it's been scaled back to just the better months. Now, for some environmental reason that I don't fully understand, they have to refuel ships with a rig like this. I don't know why, but that's Neil de Quebec testing the refueling rig. Finally, I'll end up with the first colour ceremony at Naval Facility in the Pacific, which I think is probably a good way to end the talk about Navy and exploration. So there we are. Thank you. If there are any questions, I'll try and answer them.
The flags are the other way around these days, aren't they? The ensigns, the white one up top, and the jacks are red.
At one time they shifted to the American system. Now they've gone back to the same system that we use. And so the national flag is now a jack, and that is the ensign, which is the correct way of doing it.
Roger, during those periods where the passage is not entirely ice-free, how severe does the ice have to be before ships can't enter? For example, are some commercial ships going through with strengthened hulls that allows them to passage through light ice?
Not very many. It requires in the midwinter, it requires a polar icebreaker. There was an American tanker years ago, I'm trying to think of the name of it, Manhattan, I think, which was given an ice-breaking valve and went through in the winter. The status of the Northwest Passage is a bit tricky because it really is an international strait and everyone has a right to go through it. But the Canadian government said, no, it's not an international strait. This is the same sort of thing that China and Russia would do. It's not an international strait. That we're closing lines across the exit and entrance of the strait, and they ask, I guess that's the word, any ship that's going to go through the passage to get clearance first, and they would not normally give clearance for something in the winter. The ice comes and goes. It's getting less all the time, but this last winter, for example, was the second largest extent of sea ice in the last 18 years, so you can't really guarantee that.
What about the submarine bursting through the ice? Would that cause any physical damage to the...
The only knowledge I have of that is from a book on the Nautilus when she went through, and initially they had some problems initially, because it wasn't strong enough, but I'm sure that any nuclear submarine that's operating there now will not have any difficulty.
Okay. Roger, that photograph you showed towards the end of the rig to refuel the ship, with the rig up in the air. Yes. Would that be because the ground is so cold that the oil wouldn't flow across it?
No, it's something to do with some environmental reason, which I haven't had time to sort out. I only just discovered this recently, that there is a reason that they have to do that. I'm trying to find out, but I don't know the answer at the moment.
But it looks like it might be a probe refueling system.
Yeah, I'm sure it's
It's
simply a modification of the standard refueling system.
Roger, too, I noticed back one of the slides mentioned Fram in about 1893 or something like that.
Yes.
There's a ship up on the Hard in Oslo called Fram, and I'm wondering if it's the same one.
I would suspect it's the
It's
same
out in
one.
the open too.
Yeah.
It's not really being looked after. It's
It would almost certainly be the same one.
Roger, can you make a comment about the economic benefits for being able to passage through the Northwest Passage in terms of trade? I mean, obviously it's a shortcut for ships that want to trade between Pacific parts of the world.
Yeah, I'm sure it's very important. For example, People's Republic of China, which considers itself a near Arctic nation, wants to use it as part of its Arctic Silk Road. They've bought icebreakers and they're operating in that area, looking for better ways to get through. So, you know, the Chinese are interested in a big way. And I think they also use the northeast because it's much faster than going around the end of the southern continents or through the canals.
One other question, if I may. The Erebus, and I've forgotten the other ship's name. Terra. Franklin's expedition. I know they've discovered them now, and Michael Palin wrote a very interesting book about it. What's the intention there? They recorded, photographed as much as they can, and that's it. I guess they're not going to try and consider any sort of salvage or any sort of recovery operation.
I find it rather strange, really. There was a lot of publicity when they found each of the ships. One of them is pretty well wrecked. The other one is in very good condition.
Yeah.
But very little information has come out since then. I know that the federal government and the government of the Scottish province, Nunavut, they're both involved in it. And I think it's being reserved as a national historic park, but very little information is coming out, and I don't really know why. Yes, Jim.
It wouldn't have been because, did they find any bodies?
I'm sorry, I couldn't hear.
Did they find any bodies or anything like that with the...
Not that I'm aware of, no.
No, I was wondering if it might have been the reason, a bit like the Mary Rose, you know, they've kept all the bodies that they're in a big, what's the word I want, laboratory somewhere at Oxford, I think. They've actually, all the bodies that were left in the Mary Rose, about half the total crew, were actually taken out of the ship and kept in this laboratory.
No,
They're still
I
researching
don't think
them.
anyone was in the ships. I think they all left the
They-
ships
they'd
long
all
before
left
they,
them,
long before
yeah.
they sank.
Oh.
There is actually film taken inside the second ship to be discovered.
Oh yeah.
And they were thinking that, you know, all the cupboards and drawers are there. What were they going to find when they opened them? I don't know.
Yeah, I think any of the ships would have been trapped in the ice were well and truly evacuated before they went down. And if you think the Shackleton's expedition as well, nobody was lost in the ship itself.
Yes.
It's amazing.
Way in other places, which is amazing.
This is the thing, yeah. Franklin.
Roger, thank you. I think, is there any other questions for Roger? I think that was a fascinating insight into this unusual part of the world. Most of us perhaps don't give it too much thought from day to day. Certainly the exploration has gone on over hundreds of years. It's quite remarkable. I was delighted that you mentioned Harrison's Fox. I'm a bit obsessed by Harrison's Fox, and so is Carol. In fact, we've even got the DVD. It's a fascinating story if you've not seen the story of Harrison's Fox and how he invented it and struggled for 40 or so years as an old man to get his
Trying
invention.
to get money. Yeah.
Yeah.
The government was very stingy about
The
it.
Queen Anne Prize, I think it was.
And if I could just continue that for a second, I mentioned the two Germans who worked on the lunar problem. The first one, who did most of the work, Professor Meyer, he died before he could begin getting money. And amazingly, the government gave money to his widow.
And Harrison's Fox are still in existence and operate.
Yes.
Yeah,
Great.
And it's interesting that Harrison was carpenter, so his first one was made out of timber.
And the man who restored the box was a little bit shell-shocked and naughty. Some might say he was on the spectrum. He was absolutely obsessed to the detriment of his marriage and those other things and getting these clocks back to work.
Did the bounty chef, trying to think of his name now, getting on the bounty, Bly, did he have a Harrison's clock on board?
No, I think Cook did.
You don't think so?
No,
Cook or Flinders.
wasn't allowed to take a Harrison clock because of the war. So they got Kendall to make a copy. And Cook took a K1. They numbered it. So K1 was made the equivalent of H4,
Yeah.
which was like a big watch.
Like 55 clock.
I don't think so. You'd be accused of
It's
stealing.
amazing that a present digital watch is almost as accurate.
Yeah. Well, I mean, I still remember my time navigating the sea when we had a deck watch.
Yeah.
And every day, luckily, we had time signals globally, but the deck watch, you could measure the time against Greenwich time, but you had to mind daily how many seconds fast or slow the deck watch was running. So that when you were taking your sights day after day after day, you had to add in your few seconds of error.
There's a chap out in Mulgrave called Roger Peters. He's recognised as the top chronometer bassoon, if you like, in the Southern Hemisphere. And he did up our Swiss nomad maritime chronometer, but he wouldn't give it back until it was accurate within 1/100th of a second over a week. That was incredible.
Yes, I think.
Thank you.
Well,